Hello everyone. Today we'll be looking at GATE 2015 Chemical Engineering question number 55. Adsorption on activated carbon is to be used for reducing phenol concentration in wastewater from 0.04 mole per liter to 0.008 mole per liter. The adsorption isotherm at the operating temperature can be expressed as Q is equal to 0.025 C raised to 1 by 3, where Q is the phenol concentration in solid in mole per gram solid and C is the phenol concentration in water in mole per liter. The minimum amount of solid required per liter of wastewater up to 1 decimal point is dash, and this is a question from adsorption part from mass transfer operations. The reference NPTEL lecture series can be found for the same in lecture 2, week 10, stage-wise and continuous adsorption, mass transfer operations 2 by Professor Chandan Das, Department of Chemical Engineering, IIT Guwahati. So let us write down the given data. So they have asked us to assume that 1 liter of wastewater is being fed into the distillation column. So the basis is 1 liter of solution or wastewater fed into the adsorption column. That means L is equal to 1 liter. Now, other given data are C0 is equal to 0.4 mole per liter, C1 is equal to 0.008 mole per liter, and the adsorption isotherm is equal to Q is equal to 0.025 C raised to 1 by 3. Now, here C is the concentration of phenol in the wastewater. So C0 is the initial concentration of phenol in the wastewater, and C1 is the final concentration of phenol in the wastewater after the adsorption has taken place. Then Q is the concentration of phenol in the solid adsorbent. Now, let us represent the data that we have in pictorial form. So this is a adsorption column. We have S, which is the flow rate or weight of activated carbon being fed into the system. Q0 is the initial concentration of phenol in the activated carbon, and it comes out as Q1, which is the final concentration of phenol in the activated carbon. Then L represents our wastewater flow rate, and L is equal to 1 liter, and initial concentration of phenol in the wastewater is 0.04, and the final concentration of phenol C1 is 0.008. Writing a steady state solute balance for the system. The solute in is equal to solute out. So SQ0 plus LC0 is equal to SQ1 plus LC1. So Q0 is equal to 0 because the activated carbon doesn't have any initial phenol concentration. That is, it is basically pure activated carbon. So SQ0 plus LC0 is equal to SQ1 plus LC1, and SQ0 is 0. Substitute the values for L, C0, L and C1. We'll get 0.04 is equal to SQ1 plus 0.008. Let's take this as equation 1. So given the adsorption isotherm as Q is equal to 0.025 C raised to 1 by 3. Now, at minimum solid required, the concentrations Q1 and C1 will be at equilibrium. That means the concentrations Q1 and C1 will satisfy this isotherm equation. So we can write Q1 is equal to 0.025 C1 raised to 1 by 3. We have the value for C1, substitute it, and we can find the value for Q1, which is 5 into 10 raised to minus 3. Now we have all the values required to find the required answer. Substitute Q1 in equation 1, which is 0.04 is equal to S into Q1, which is 5 into 10 raised to minus 3 plus 0.008. Now substitute, now solve this equation and we'll get S is equal to 0.04 minus 0.008 by 5 into 10 raised to minus 3, which is 6.4 grams. And this 6.4 grams is the minimum amount of solid required for the adsorption to happen. Thank you.